Alright, so now in the last video we saw the key concepts between the Thevenin and the Norton equivalent circuit, and we saw why these two concepts are very useful. So let's just apply those on this circuit here to find the Thevenin equivalent across these two terminals. So the first thing is to find VOC, and for that I'll just open these two terminals and find this voltage here. So to find it, I'll just apply any circuit analysis tool we have learned. I'll just apply mesh analysis. So one thing to remember is that the current through this branch, it would be zero because there is no resistor component here. So now, so the only current flowing would be here, 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 and then here. So I'll just apply the mesh analysis. I can clearly see that the super mesh would form here. So there's I1 and then there's this I2. So KVL on super mesh 1, 2, that would be -3. I'll just start off from this point and go here, plus 2000 I1 because it's 2 kilo ohms, and then I will move here and then plus 5000 I2. This is one equation, and because it's a super mesh, the another equation would be I1 minus I2 is equal to 0.007 amps, 7 milliamps. So if I solve these two simultaneous equations, I would get these two values. Or solving those two simultaneous equations, they gave me these two values. I1 is 0.00542 amps and I2 is minus 0.00157 amps, even though it does not look like a 5. So these are the two currents I get. Because I think you all know by this point is that this negative current, it means that I assumed the wrong direction. It has no problem with the answer. So now let's find VOC. So I need to apply a KVL from any side. I will just start off from this side. No, I can even go from here to here, or I can go from here all the way back to here. So I'll just start off from this side, applying the KVL, -3. Then there's this 2 kilo ohm resistor, so 2000 into I1. Then there's this 1000 ohm resistor, but there's no current flowing through it because it's an open branch. So plus 0 plus VOC is equal to 0. Solving this, I get VOC as, so VOC would come out to be 7.85 volts. So this is our VThevenin. So now we have gotten VOC. Now we need to find R Thevenin. So clearly there are no dependent sources in the circuit. So I can either use the short circuit current or even the direct resistance equivalent to find R Thevenin. So I'll just use both methods to make things more clear. So the first easier method is to just open the terminal and remove all the sources and find the resistance. So I'll just do that. So I replace the voltage source with the short circuit and I replace the current source with an open circuit. And now let's find the resistance. These two, they are in parallel, and I'll just combine them. So that would be 10 divided by 7 ohms, and then that new resistance, it would be in series with the 7 kilo ohm resistor. By the way, this is kilo ohms. So the new resistance, the Thevenin resistance, would be 10 by 7 plus 7. This is equal to, also something to keep in mind, this was not 10 kilo ohm, it was 1 kilo ohm. So this is 1. So the Thevenin resistance would be 2.5 kilo ohms. So this would be our Thevenin resistance if we use the simpler method. Now we can also find ISC, so let's do that. So now I need to find this ISC to find our Thevenin resistance. So I can just apply mesh analysis again. So this is mesh 1, this is mesh 2, and now there would be a mesh 3 too because there is no open circuit here. So KVL on super mesh, it would be -3 plus 2000 I1 plus 5000 I2 is equal to 0. This would be our first equation. There would be a KVL on mesh 3. So that would be 5I3 minus I2 plus 1, I'm sorry, this would be 5000. 1000 I3 is equal to 0. And then there would be a third equation due to the super mesh. I1 minus I2 is equal to 0.007. If you solve all of these, the answer you would get is I3 would be 3.235 milliamps, and clearly I3 is what ISC is, so this is also ISC. We had calculated VOC as 7.85 volts, so we can just use this formula to find the R Thevenin, and that would be the same value, 2.85 kilo ohms. So these are the two methods you can use to find the Thevenin equivalent. So if I just sketch the new Thevenin equivalent circuit, it would be this. This is the Thevenin equivalent circuit. There's this VOC, then there's R Thevenin, and there's the resistor we are interested in. So this is how you can use the concepts of Thevenin equivalent or the Norton equivalent to solve circuits and make them even more simpler. So in the next video, we'll solve one more example to make the concepts even more better.